Don't try to understand it, just feel it.
Hi guys, yet another video on race condition. And I'm going to say it again, they are a piece of art. And in this video, we are going to learn about an expert level lab, which is supposed to be the most difficult lab offered by Portswigger platform on race conditions. So without much further ado, let's get started. So this is the lab that we're going to be attempting. It's called partial construction race conditions. And before getting into this lab, I suggest that you should go through all the content that is provided here. It will clear a lot of confusions that you might have, and it will also give you a few tips on how to inject certain payloads so that you'll be able to better exploit the lab. Yeah, this is the lab and let me access it. Let me just copy this URL into my testing browser. There it is. So what are we supposed to do in here? This lab contains a user registration mechanism, and it is vulnerable for the race condition vulnerability, which enables us to bypass email verification and register with an arbitrary email address that you do not own. Generally, when you register an account in any platform with an email ID, a verification email will be triggered to your inbox, right? When you open it and you will click on a link provided there, or you will get an OTP there, or something like that. A verification mechanism that actually ensures that you are the owner of that particular email address that you have provided just now. And in this lab, we are supposed to create an account, but we don't have access to that inbox. And so we should be able to bypass that verification step altogether. Let's see what we are dealing with here. As mentioned, there is a registration mechanism. Daredevil is the username. Daredevil, and they have asked us to use this email ID. Random password. Okay, it shows that an email is sent to that email address, which is daredevil@gin and juice shop for a verification, but we don't have access to that inbox. Let's see what we get if we try to register with the same email ID once again. I'm just testing all the possibilities. Okay, it shows that an account already exists with that user. Cool. Let me just copy that request, which was user to register this. Repeat. User registration. Yeah. But to actually bypass the step of verification, we should at least know what that request might even look like. You should be able to send that request at the particular time as all race conditions go. But you should be able to know what that request looks like it is a post request or a get request, and what parameters is it accepting, and what kind of key it is expecting, etc. So I navigated all around the web page and all the other endpoints we do have, but I haven't gotten anything. And then when I searched in the JS files, I've gotten to know that there is this file called users.js. And this has a function called confirm email, which actually gives us an insight into what that might look like. So it is a post request, and it is a post request to this endpoint /confirm. And the presence of a question mark indicates that there are more query parameters to it. And that query parameter name is token. So I think we have gotten enough information that we need. So I'm making a request to that endpoint /confirm with a random token, something. It doesn't have to be 1, 2, 3, 4. Okay, I made a get request. When you enter it in a browser, normally it will be, a get request will be made. So hopefully when I click on confirm here, a post request will be made to the server. Yes, a post request is made. But as it is saying, the token is incorrect. Obviously, right? We don't have access to that inbox, and so it is supposed to be an incorrect token. Incorrect array. Okay, so let me just copy that request. This is verification. So now I'll be explaining what we are dealing with in the backend here and how the flow in the backend might be going and what vulnerability we are going to exploit here. I've made a tiny presentation. So there is a user who wants to register an account in a platform and he sends a request with create account to the server. Cool, right? And what we expect the server to do when you send a request to create account, it will create the account. That's what we just think of it as. But there are more minute steps that happen sequentially in the server end, and there is a delay between all those requests. We'll see them now. This server, what it actually does is it will send all the details that you have submitted to a database server to be stored there. Initially, it sends a request to create that user account. It will create a new entry, a new row in the database, and it will add all new details to it, your name, email ID, address if provided, etc. and all. And then it will assign a specific unique key to that particular user. And what is this used for? You receive a verification email from the server, right? And when you click on it, your account will be activated. That's all we know. But if you actually observe that URL very clearly, there will be a random token at the end of that URL, which is generated randomly by using a random generator, like I've described in the last video. If you haven't watched it, watch it. The link to that is on the top right corner of the screen. But if you see here, in the first request, a user account is created, and after the second request, a unique identification or the verification key is assigned to that user, and there is a slight delay between those requests. And that delay is in the order of a few hundred milliseconds, maybe 200 or 100 milliseconds. That's it. It's incomprehensible to human eye, but it is a lot in terms of computation power. So, in theory, we are supposed to exploit that time gap and send a verification email during that delay, which we call as a race window. So, during that delay, no key is assigned to that user, and so it is actually an empty string or an empty array. So, even though you don't have access to the inbox or even though you don't know the exact key, you can send an empty array and then successfully bypass the verification step altogether. So let's see how we are going to do that practically. As you know, I have captured those requests and I have saved them. Let me try to group them and send both of the requests parallelly in the hopes of hitting that sweet spot. And let me change the username since it is already registered. Okay, our registration email is sent, but it shows incorrect array. Maybe I'll send this request a lot more. When you send a lot more verification requests, maybe at least one will hit that sweet spot, right? Some requests might go earlier than the registration request itself, and some might go later, a lot later, that the delay is already gone. But there might be a better chance at getting at least one request to penetrate the sweet spot at the particular race window. So in hopes of getting it properly, I'm doing this. But let's check our luck. Okay, an email is sent. Incorrect. Incorrect. Nothing. Incorrect. Yeah, none of it worked. And why do we think that is? User registration took 395 milliseconds to return the round trip. This took only 284 milliseconds. 284. 284. 284. They are nowhere in sync. And since this is an expert level lab, I assume that we should bring the big guns here, which is the turbo intruder. Yeah, and I'm going to select single packet attack here. This is the sample code provided by them. And this is the registration request that we had copied from there. The username should be changing every time, right? Since once a user account is created with a username, another can't be created and it is giving out an error. So I'll make this a variable which will be changed with every request. And here we also want the verification request that we should send. So I'm going to copy that. Let's name it request 2. This is just simple Python, don't panic. So I'll explain to you the logic of what I'm going to do now. So as per my logic, I'm going to send this register request once, and I'm going to send this verification request a lot more times, like 25 or 50, in hopes of actually hitting that sweet spot, as I've told you, that race window. So let's modify this logic according to that. Let's give it a name. Okay, and I also told you that this username needs to be changed every time, right? So I'll create a variable here, username, which is, let's just say Daredevil, plus string of this number that we are going to use, which will be changing during every iteration. Let's just say 10, 30. And that username will be supplied here. So what this function does is, it will take this username which is generated during every iteration. In the first iteration, it will be called Daredevil 10. And in the second iteration, it will be called Daredevil 11. And it will take this username and it will substitute this percentage S marker that we have here with this username. So with every iteration of sending that request, it will be a different one. So we don't get that error. And here I'm going to send, let's just say 25 times. Let's not overwhelm the server. I'm going to send the second request, which is a request 2, the verification request. And it doesn't have any variables in it. It is just a static request, right? So it equals 0. And now you should open that gate. So what we are actually doing here is, in the first loop, we are creating a username and we are sending that request altogether, the register request. And in the second loop, or in the nested loop, we are sending the verification request multiple times, which is 25 times to be exact here. And then we are opening that gate, which means you will send all those requests at once, parallelly. So let's try. I'll sort this as per the status codes. Okay. 200 means success, but the registration has been successful, not the verification, for Daredevil 10 and 11. Okay, let me reconfigure it. Let's try another approach. I'm here to reconfigure it again. Let's change the username ID. Right? Let's try once again. Still ain't working. Let me just reconfigure it again in hopes of getting a different output using the same input. 30. This time I'm going to increase the number of requests here. Spider-Man. Shrimps I don't see any problem with this here. So let me open the gate again. Good. Finally we have gotten this. See, these are the registrations that have gotten successful, 200 status code. And here you have this confirmation request which gave us at 200 instead of a incorrect token or incorrect array or something. Account registration for user Spider 10 is successful. Good. Good. After a long, long wait, we are successful. Let's go to home. Let's try to log in. Spider 10. And the password that I have used, which was Daredevil. It's the same for everyone. Let's see if we are able to log in. Right. Did you see that? We didn't have access to this mailbox, but we were able to bypass the entire verification step just by using race conditions based on the concept as I have explained before. And one thing that we should do here is go to admin panel and delete this user file. See, we have solved the lab, but this required a lot of patience and a fair amount of luck to succeed. So there is no certainty with race conditions, but they are some of the best vulnerabilities that you'll ever get to see because they are purely technical and you'll have to use your imagination a lot to make sense of what might be happening in the backend. So just don't let your curiosity die. Keep learning. Bye bye.